We are going to learn about calculating the inverse of a 2 by 2 matrix. And there's a specific formula that we need to use to calculate the inverse. So let's say we have matrix A with the entries little a, b, c, and d. The formula for finding the inverse of a 2 by 2 matrix is 1 over AD minus BC times D, negative B, negative C, and A. AD minus BC represents the determinant of matrix A. I do want to clarify something. If you calculate AD minus BC and the value equals 0, the inverse of the matrix does not exist. This is because you cannot divide 1 by 0. So if AD minus BC equals 0, the inverse of the matrix does not exist. Now, let's go back to the inverse of the matrix. Entries A and D get switched, and B and C are negatives. If this does not make any sense yet, let's do some practice problems. What is the inverse of matrix B when B equals 3, 5, 2, 9? So first, let's check that this is a 2 by 2 matrix. This matrix has 2 rows and 2 columns, so it is a 2 by 2 matrix. Remember, we cannot use the formula we learned for any other matrix size other than a 2 by 2 matrix. Now, let's find the inverse of this matrix using the formula we learned. Let's label what our A, B, C, and D are. A equals 3, B equals 5, C equals 2, and D equals 9. So let's substitute the values for the formula above. So we get inverse B equals 1 over 3 times 9 minus 5 times 2 times the matrix 9, negative 5, negative 2, 3. We then get 1 over 27 minus 10, which equals 1 over 17 times the matrix 9, negative 5, negative 2, 3. Now, we multiply the scalar 1 over 17 by each entry in the matrix. We then get the matrix 9 over 17, negative 5 over 17, negative 2 over 17, and 3 over 17, which is our answer. This is the inverse of matrix B. Let's try another example. What is the inverse of matrix H when matrix H equals negative 4, 1/2, negative 6, 2? So first, let's check that this is a 2 by 2 matrix, as we cannot use the formula we learned on any other matrix size other than a 2 by 2 matrix. Since this has 2 rows and 2 columns, this is a 2 by 2 matrix. Now, let's label what our A, B, C, and D are. A equals negative 4, B equals 1/2, C equals negative 6, and D equals 2. So let's substitute the values for the formula. Recall that the formula is 1 over AD minus BC times D, negative B, negative C, A. So we get inverse H equals 1 over negative 4 times 2 minus 1/2 times negative 6 times the matrix 2, negative 1/2, 6, negative 4. We are just substituting the numbers in the formula. When we simplify this, we get 1 over negative 8 minus negative 3 times the matrix 2, negative 1/2, 6, negative 4. We get 1 over negative 5 times the matrix 2, negative 1/2, 6, negative 4. When we multiply the scalar by each entry in the matrix, we get the matrix negative 2 over 5, 1 over 10, negative 6 over 5, 4 over 5. Therefore, the inverse of H is this matrix, which is our answer. Let's try another example. What is the inverse of matrix K when matrix K equals negative 5, 1, 3, 4, 7, 2, 8, 7, 3? So first, let's check that this is a 2 by 2 matrix. And this is not a 2 by 2 matrix. This is a 3 by 3 matrix, as it has 3 rows and 3 columns. Therefore, we cannot use the formula we learned in this video to find the inverse of this matrix. However, this does not mean that the inverse of matrix K does not exist. Since the number of rows equals the number of columns, there is a possibility that the inverse of the matrix exists, but we did not learn how to find the inverse of the matrix yet. Notice how I said that there is a possibility of finding the inverse of this matrix. Like we discussed earlier, if the determinant of the matrix equals 0, we cannot find the inverse of the matrix. We do not know how to find the determinant for the matrices other than a 2 by 2 matrix. Calculating the determinant for a 3 by 3 matrix is different than that of a 2 by 2 matrix. So the answer for this question is that there is a possible inverse matrix K. So the answer is that there is a possibility that the inverse matrix K exists, but we do not know yet how to find the inverse matrix, as this video is only for 2 by 2 matrix. I put this problem in so that you know when to use the formula 1 over AD minus BC times D negative B negative CA. I want to clarify that's only for 2 by 2 matrices. Let's look at another example. What is the inverse of matrix M when matrix M equals 4, 5, 2, 7, 5, negative 2, negative 1, 4? So first, let's check that this is a 2 by 2 matrix. And this is not a 2 by 2 matrix, as this is a 4 by 2 matrix, as it has 4 rows and 2 columns. Therefore, we cannot use the formula that we learned in this video to find the inverse of this matrix. But how is this example different from the previous example of the 3 by 3 matrix we just did? In the previous example, we concluded that there is a possibility of having the inverse matrix, since the number of rows equals the number of columns. The previous example had a 3 by 3 matrix, which is 3 rows and 3 columns, and since 3 equals 3, there is a possibility of having an inverse matrix. However, this example deals with the 4 by 2 matrix, where 4 is the number of rows and 2 is the number of columns. Since the number of rows do not equal the number of columns, we cannot find the inverse of the matrix in general. In the previous example of the 3 by 3 matrix, there is a possibility of calculating an inverse matrix that we have not learned yet. However, in this example of the 4 by 2 matrix, there is no inverse matrix possible. The inverse of the matrix exists only when the number of rows equals the number of columns.